For this video, we will be discussing the derivative of implicit functions. So what are implicit functions? So far, we have been dealing with explicit functions. So explicit functions, it is defined as y is equal to f of x, or the functions given are in the form of y is equal to whatever x. Okay, so it is explicitly defined. It's called an explicit function because y is explicitly defined in terms of x. Okay, so meaning on one side of the equation it's only y, and on the other side of the equation it's only x. So say for example, so we have here y is equal to 2x cubed plus 3x minus 1. So that is an example of an explicit function because y is clearly defined in terms of x. So however, in implicit functions, in explicit functions, so y is not clearly defined in terms of x. And the terms of the functions are combinations of x and y. So its connotation is f of x and y is equal to 0. So an example of that is x cubed plus y cubed is equal to 3axy. Okay? So in this case, y is not clearly defined in terms of x. Okay? But of course, we can use our algebra, the laws of algebra, to express y in terms of x. Okay? So we can actually convert the implicit functions into explicit functions using algebra. Okay? But by doing so it may not be easy, or it may be very difficult. Some of the functions are very difficult to convert from implicit to explicit. Okay, so what we do in taking its derivative is that we don't convert it anymore to the explicit form. Okay, so because again, as I've said, it's some functions are very difficult to convert to explicit functions. If not difficult, it's impossible or nearly impossible for us to express y in terms of x. Okay, so what we do is we take the derivative of the implicit functions directly. Okay, so derive directly the implicit function. So in taking the derivative of implicit functions, so differentiate each term of the function f of x and y is equal to 0 with respect to x, bearing in mind that the derivative with respect to x of y raised to n is equal to n times y raised to n minus 1 times dy over dx. Okay, so it's like the general power formula. So we need to multiply dy over dx whenever we encounter the derivative of y. Okay, so later on, when we finish differentiating each term of the function, we will collect all the dy over dx, because the dy over dx, that is the derivative. Okay, so we will collect all dy over dx and then express it in terms of x and y. Okay, so say for example, so we have here, so find y prime. So y prime is also dy over dx. So find y prime if we have x squared plus 4xy plus y squared is equal to 1. Okay, so this is clearly an implicit function. Okay, so since y is not clearly defined in terms of x. Okay, so what we need to do, so we just proceed directly by differentiating each term of the function. Okay, so differentiating or deriving it with respect to x. Okay, so deriving, so the first term we have here x squared, so derive x squared in terms of x, so that will be 2x. Okay, so plus, so we have here a constant, so we write the constant 4, and then deriving x and the product of x and y. So the product of x and y will still follow the product rule. So first factor multiplied by the derivative of the second factor plus the second factor multiplied by the derivative of the first factor. So x for the first factor multiplied by the derivative of y with respect to x. So that is dy over dx or y prime. Okay? Plus the second term y multiplied by the derivative of the first factor, no, x with respect to x. So derivative of x with respect to x, that is 1. Okay? Plus the derivative of y squared with respect to x. So following this, so this will become 2 times y raised to 2 minus 1. Okay, so that is 1. And then times dy over dx. So dy over dx is still y prime. Okay, is equal to derivative of a constant. So we have 0. Okay. So what we need to do now is collect y prime, no, and express it in terms of x and y. So meaning we will transpose all terms without the y prime on the right side, and then retain all the terms with y prime on the left side. So but first we'll distribute this. So we will have 2x plus, so this will become 4x y prime plus, so we have 4 times y, so we have 4y, okay, plus 2y y prime is equal to 0. So as I've said, those with terms without y prime, so transpose on the other side. So we will have 4x y prime, okay, plus 2y y prime is equal to, so transposing 2x, it will become negative 2x, transposing 4y, it will become negative 4y. Okay, so next, factoring y prime. Okay, so factoring y prime, so what will remain is, we'll have y prime, so factoring out y prime, so what will remain here is 4x. Here we have plus 2y. Okay, is equal to, so we have a common factor here of negative 2. So factoring out negative 2, and then this will become x, then this will become plus 2y. Okay, so the next thing to do, so eliminate the coefficient of y prime by dividing both sides of the equation by 4x plus 2y. Okay, so divide this by 4x plus 2y, and on the other side divide it also by 4x plus 2y. Okay, so this will be cancelled, so therefore y prime is equal to, we also have a greatest common factor here in the denominator, so we'll also factor that out. So negative 2 times x plus 2y, greatest common factor here, we also have 2, and then what will remain is 2x plus y. Okay, so 2 will be cancelled, so therefore our y prime is equal to, so negative x plus 2y over 2x plus y. Okay, sorry, so this is our derivative. Okay, so that's how you derive implicit functions. Okay, so let's proceed with our second example. Okay, so for our next example, so we have this one. So find dy over dx for the given x squared plus y squared squared is equal to ay cubed, where a is a constant. Okay, so deriving this with respect to x. Okay, so derive directly, no, each term. So for the first term here, we can derive this using the general power formula, no, where our u is x squared plus y squared and our n is equal to 2. Okay, so deriving, so using the general power formula, so we write first the n. Okay, so n is equal to 2 multiplied by our u, which is x squared plus y cubed. So it's x squared plus y squared raised to 2 minus 1. Okay, multiply by the derivative of u, no? So what is the derivative of x squared plus y squared? So the derivative of x squared is 2x, okay, with respect to x, and the derivative of y squared is plus, so 2y and then y prime. Okay, so that's it. So it's equal to a constant multiplied by the derivative of y cubed with respect to x, so that is 3y squared y prime. Okay, so just like earlier in the previous example, so all with y prime transpose on the left side, and then all the terms without y prime transpose to the right side. So but since we have here this, so we still need to distribute this, no, for 2x and 2y y prime. So rewriting, so you have 2 times x squared plus y squared times 2x plus 2y y prime is equal to, so this will become 3a y squared y prime. Okay, so distributing distributing 2 and x squared plus y squared here, so this will become 2 times x squared plus y squared times 2x, so that will become 4x times x squared plus y squared. Okay, and then again distributing this to 2y y prime, so that will become plus we have 4y y prime times x squared plus y squared. Okay, so it's equal to 3ay squared y prime. Okay, so since we have a y prime here, so transpose to the other side. So since this term does not contain y prime, so transpose it on the right side. So it will become 4y y prime times x squared plus y squared, so for this term, and then transposing this, so minus 3ay squared y prime, okay, is equal to, so transposing this, so it will become negative 4x x squared plus y squared. Okay, so after that, so we collect the common factors here. So obviously y prime is a common factor. We also have y as a common factor, so therefore factoring out y and y prime. So y and y prime. So what will remain here is 4 times x squared plus y squared. Okay, and then factoring y prime from 3ay squared y prime. So that will be minus 3ay. Am I right? So minus 3ay. Okay, so that is equal to negative 4x x squared plus y squared. Okay, so the next thing to do is divide each side of the equation, no, in such a way that the only term that will remain on the left side is the y prime. Okay. Okay, so sorry for the interruption. So, where were we? So, we need to divide both sides of the equation in such a way that only y prime will remain. Okay, so therefore we have to divide it with y and 4 times x squared plus y squared minus 3ay. So we also have to do that on the other side. So y, and then times 4, we have x squared plus y squared minus 3ay. Okay, so this will cancel out and the y will cancel. So therefore, we will be left with y prime is equal to so we will be left with we have here negative 4x times x squared plus y squared over y. So removing the grouping sign here, so we have 4x squared plus y squared minus 3ay. Okay, so this is our derivative or answer. Okay, so for implicit functions, so you should be very good with your algebra, no? So because the first part is fairly easy, but the second part, now where you collect the derivative, the y prime, so this will really test your knowledge in algebra. Okay, so kindly don't forget about your fundamentals, factoring, and so on. So good luck.